All right, in this video, this is the third video dealing with volume, and we're still talking about prisms and cylinders. I just want to make sure you have plenty of examples. I know the notes are getting long, and I know that this is going to be a long time you're spending watching the videos, but you know what? I think it's better to have more examples than to get to these problems and not know what to do. Here we have a hexagonal prism, six-sided, right? And the hexagon is a regular hexagon. I know it doesn't say here, but that's going to be an important part of it. This is a regular hexagon. I need to find the volume of this shape. This is definitely a tough problem because I need to find the area of this base first. When I find the area of the base, I'm going to multiply it by the height, which is 20, and that's going to give me the volume. So most of the work is going to be spent finding the area of that hexagon. Well, here we go. Here's what I know. I'm going to attempt to draw a hexagon. I'm not going to be very good at it, but it's going to look something along the lines of this. I know that I have a base of 10. So how to find the area? Well, I know that the formula area is 1/2 NSR for a regular polygon. I know that in this case the N is 6 because there are 6 sides. I know that S is 10 because that's the side length. So really, R is going to be the trouble. And remember, R is the apothem length. It's this distance right here. What is that? If I can figure that out, then I can go through and find the area of the pentagon. Well, in order to find the area, or find the apothem length, what I have to do is I have to look at this like a right triangle, right? But no longer is the base of that triangle 10, it's half of that, it's 5, right? And I'm looking for R. Okay, next step. This is a hexagon, right? And I know that if it's a regular hexagon, then I can use the n minus 2 rule. I can say that 6 minus 2 is 4, and 4 minus 2 times 180 would be 720. And so I have 720 degrees in the inside of this pentagon between the 6 angles. So if I cut that into 6, 720 divided by 6 is 120 degrees. I know that each angle in here is 120 degrees. We've done a lot of this, haven't we? But you know what that means? That means that this thing in here is 60 degrees. All right, fantastic. So I've got a 60-degree angle inside of my triangle. It's not 120, right? Cut it in half, 60. I've got a 30, 60, 90 triangle. And the 5 is the short leg. That means the long leg is 5 with the square root of 3 tacked on. Okay, now we know the apothem length is 5 square roots of 3. Now it's time to multiply it out. What is the area of that pentagon? Half of 6 is 3. 3 times 10 is 30. 30 times 5 is 150. So I have 150 square roots of 3 total. There's the area of my base. The area of my base, so if volume is area of the base times the height, that means the area of the base is 150 square roots of 3, and the height is 20 units. So I take 150, I multiply it times 20, I have 3,000 square roots of 3 is the exact dimensions. Let's stick with centimeters. Let's say everything was in centimeters, okay? That gives me cubic centimeters for the volume of that shape. If I wanted to, I could take 3,000, I can multiply it by the square root of 3, which is 1.7, and that gives me 5,196.2 for an approximation. 5,196.2 cubic centimeters would be a good approximation of that volume. Okay, a couple of things to mention before we go into pyramids and cones, so just to wrap up this video. First of all, what happens if the shape is slanted? Okay, what if it looks like this? Well, it turns out that when we multiply the area of the base, by the way, that's the same thing as a capital B in a lot of pictures. The area of the base is capital B, capital B. If I take the area of the base times the height, even if it's slanted, I only care about the vertical height, not the slanted height. That is extremely important to remember because with surface area, we cared all about the slant height. With volume, we care all about the vertical height, and that's going to be one of the things you're really going to have to just take some time and pound that into your own brain somehow, some way. With volume, we care about the vertical height. And what you can think about it is like this, okay? If I had a stack of pennies, like a right cylinder, and let's say that there were 10 pennies in the stack, okay? Well, there would be a certain amount of space that those things would take up in 3 dimensions, right? 10 pennies, I could find the area, the volume of each penny, and multiply it by 10, okay? So even if I took that stack of pennies, the same stack of pennies, and I just made it all crazy and I didn't stack them vertically, okay, they would take up the same amount of space. So I really don't care so much about how they're stacked. It's just how many of them there are, right? I could find the area. I would do area. It would be pi r squared for each penny, and I'll multiply it by 10 or something like that. Well, here I'm doing the area, which is pi r squared again. I'm still going to multiply it by 10 because there's still 10 pennies, even though they're all cockeyed, right? So the idea here then is this dimension here is the one that's important. I'm not doing anything like this and then this and then this again, right? That'd just be crazy. So it's not that I'm doing, this. So I can do a problem like this, which looks terrible, but it's actually not that hard, okay? Volume of the cylinder, we haven't done any cylinders yet, is area of the base times the height. And the important idea here is that the height is going to be the 14, the vertical height. So if all I have to do is find the area of the base, and that's just a circle, the diameter is 18. That means the radius, the distance from here to here, is 9, right? So area of the base is pi r squared. That's 81. Better get the calculator here. I have 81 times 14, which is 1134. I have 1,134 pies for the volume of the shape, and that's in inches, so that would be cubic inches. If I wanted to, I could take it times pi, 3.14. It's approximately 3,562.6 cubic inches. But here's what I know. The question was, oh, here we have a second question. Okay. Sorry. Those look related, don't they? I apologize for that. Second problem. If the volume of a cylinder is a cylinder, so it's the area of the base times the height, right? And the base is a cylinder, so it's a circle. That's pi r squared times the height. If the volume is 108 pi, and the radius is 6, then what's the height? Right? I put in 6 for r. That's pi. This is 108 pi. Notice the pi in there. That's important because I have a pi on each side, so they go away. 6 squared is 36, so I have 108 on the left. The pi's have gone away, so that's equal to 36 times h. H must be 108 divided by 36. It must be 3. Looks like our units are in centimeters. It must be a 3 centimeter tall cylinder. Okay? I guess that really didn't have to do with the slanted thing, but that was just one way of working backwards and another problem dealing with prisms and cylinders. The important idea is here then. Okay, ready? Area of the base times the height. Even if it's slanted, we use the vertical height. And be prepared to do something like this where you're working backwards to find a dimension. There's 18 minutes worth of videos. I apologize so far. This is going to get long because we still have pyramids and cones, but like I said, I feel like more examples is a good thing in this case because you guys are going to have to do some pretty difficult problems in class.